Example 2, sketch the graph of the function f of x equals x squared over x squared minus x. So first we're going to see if this simplifies. So we're going to factor that x out of the denominator there, and you'll see that one of these x's can simplify. So here's your simplified equation, x over x minus 1, where x cannot equal 0 and 1. It's very important you write both restrictions, not just the one that canceled, not just the one that remains, and that's important. So this is a good example of seeing the one that canceled is going to tell me where the point of discontinuity is. The one that remains, or that you still see here, is the one that you're going to use as your vertical asymptote. So speaking of asymptotes, we can use the rules for horizontal asymptote in our original equation here as well, or this one. The degree in the denominator is the same as the degree in the numerator. So that means it's the leading coefficients divided by each other. So 1 over 1, if you looked here, it's the same thing, 1 over 1. So y equals 1 will be your horizontal asymptote. So we know that information. We may as well start plotting this. So y equals 1 and x equals 1. Okay, I need to find the y value of the point of discontinuity. So I want to show my work in here. What you do is you plug 0 into the simplified equation, which is right here. So we'd have 0 over, so I'm just going to put a little arrow that's the work for this. 0 minus 1. Well, 0 over anything is still 0. Well, of course that makes sense. If you have, and it's only because it's at the origin, if you have an x value of 0, the y value has to be 0. So I know that that happens to be my hole in the graph. Now, just by chance on this one, that also tells me that there's going to be no, if my curve is going to go through there, there's not going to be intercepts. But how do I figure out then where to graph it? Well, we need to do that division to put it in that form of y equals a over x minus h plus k form. So we're going to divide. So this is the equation that I'm talking about dividing. So my divisor out here. In fact, let me write this with the 0. We're really dividing x plus 0 over x minus 1. Okay, so we have 1 is my divisor, 1 and 0 is my coefficients. Bring down the 1. So we get 1 plus 1 over x minus 1. So my equation is y equals 1 over x minus 1 plus 1. So this is shifted to the right one, which confirms my horizontal or my vertical asymptote. It's shifted up one, so it also confirms my horizontal asymptote had I not thought of doing that earlier. Okay, a value is 1, so that means there wasn't a vertical stretch. So that means this is a distance of 1 and 1 from here, which only makes sense because that's the distance here. It also tells me, remember, that these were at those 1/2 points. If you're uncertain, you could always test a point. I know that because I've graphed y equals 1 over x enough to know that where it was a 2, it became a 1/2, etc., etc. And again, we don't have any x and y intercepts, but usually we do. So that's something that typically I would look at or find if needed. So no x or y intercepts, and we'll just say that that's where the hole in the graph was.